Greetings, good friends. Gather round. Today we embark on a thought-provoking exploration into DeepSeek-R1, Incentivizing Reasoning Capability in LLMs via Reinforcement Learning, a fascinating study conducted by the innovative minds at DeepSeek-AI. Imagine, if you will, the world of large language models, advanced artificial intelligence systems designed to understand and generate human-like text. These models, often abbreviated as LLMs, are trained on vast amounts of data to predict and produce coherent sentences. While they're quite adept at handling language, enhancing their ability to reason, that is, to process information and draw logical conclusions, remains a significant challenge. Today, we'll explore how DeepSeek-AI addresses this challenge by harnessing reinforcement learning to cultivate advanced reasoning in these models. At the heart of this research are two models, DeepSeek-R1-Zero and DeepSeek-R1. Let's begin with DeepSeek-R1-Zero. This model was uniquely trained using large-scale reinforcement learning without the usual preliminary step of supervised fine-tuning. Now, supervised fine-tuning is a common method where a model is trained on a dataset with input-output pairs, learning from examples provided by humans. In contrast, reinforcement learning is a training approach where the model learns by trial and error, receiving feedback or rewards based on the correctness of its responses. Think of it as the model learning from its own experiences, much like how we learn by making mistakes and correcting them. You might wonder about the results of this unconventional approach. Notably, DeepSeek-R1-Zero demonstrated significant improvements in reasoning tasks. For example, on the AIME 2024 benchmark, a challenging mathematical examination designed to test problem-solving skills, the model's pass rate increased from a modest 15.6% to an impressive 71.0%. This pass rate represents the percentage of questions answered correctly. Furthermore, when the researchers applied a technique called majority voting, where the model generates multiple solutions and the most common answer is selected, the pass rate soared to 86.7%. This performance rivals that of advanced models like OpenAI's O1-0912, highlighting the effectiveness of reinforcement learning in improving reasoning. However, the journey wasn't without obstacles. Despite its enhanced reasoning abilities, DeepSeek-R1-Zero faced issues with readability and occasionally mixed languages in its responses. In some cases, the model's answers were difficult to interpret or contained fragments from different languages, which could be confusing for users. To address these challenges, the researchers introduced DeepSeek-R1. This model builds upon its predecessor by incorporating a small amount of initial supervised data, a cold start, so to speak, and undergoes a multi-stage training process. By combining supervised fine-tuning with reinforcement learning, DeepSeek-R1 not only improved in reasoning, but also in language coherence and clarity, producing responses that are both accurate and easier to understand. The results were significant. DeepSeek-R1 achieved a pass rate of 79.8% on the AIME 2024 benchmark, slightly surpassing OpenAI's O1-1217 model. On another rigorous test, The Math 500 benchmark, which assesses advanced mathematical reasoning, it attained an exceptional score of 97.3%. In coding tasks, DeepSeek-R1 achieved a 2029 ELO rating on Codeforces, an online platform for competitive programming. The ELO rating system, originally developed for chess, is used to calculate the relative skill levels of players. A rating of 2029 places the model above 96.3% of human participants, demonstrating its adeptness not only in theory, but also in practical problem-solving scenarios. Understanding the importance of accessibility and efficiency, the researchers also explored distilling these advanced reasoning capabilities into smaller models. Through a process called distillation, they transferred knowledge from DeepSeek-R1 into smaller models based on architectures like Qwen and Llama. Distillation involves training a smaller, more efficient model to mimic the behavior of a larger, more complex one by learning from its outputs. This means the smaller models are effectively taught to replicate the performance of the larger model without requiring the same computational resources. The outcomes were impressive. The distilled model DeepSeek-R1 Distill Qwen 7b achieved a 55.5% pass rate on the AIME 2024 benchmark, surpassing larger models like QQ32b Preview. Its bigger sibling, the 32B version, scored 72.6% on AIME 2024 and an outstanding 94.3% on Math 500. These results set new records among models of similar size and demonstrate that smaller models can indeed be powerful when equipped with advanced reasoning patterns learned from larger models. This distillation process is significant because it enables broader access to high-performing models without the hefty computational costs associated with training large language models from scratch. It essentially democratizes advanced AI capabilities, making them available for a wider range of applications and researchers who may not have access to extensive computational resources. An intriguing aspect of this research is how reinforcement learning fostered sophisticated reasoning behaviors in the models. For instance, during training, DeepSeek-R1-Zero began to exhibit self-verification and reflection, allocating more thinking time to complex problems. The researchers referred to this as the model's aha moment, where it started to approach problems in a more thoughtful and deliberate manner. This emergent behavior suggests that the model was developing strategies to improve its own performance, a noteworthy advancement in artificial intelligence. Yet, challenges remain. The researchers noted issues such as language mixing, where the model inadvertently combines elements from different languages in its responses. Addressing this requires further refinement of the training process and the inclusion of more diverse language data to ensure consistency. Additionally, they aim to enhance the model's capabilities in areas like multi-turn interactions, where the model engages in extended conversations, and handling complex tasks which are crucial for real-world applications. In summary, DeepSeek-AI's work represents a significant advancement in developing reasoning capabilities within large language models. By effectively utilizing reinforcement learning, they've demonstrated that it's possible to enhance a model's reasoning without heavily relying on extensive supervised data. The ability to distill these advancements into smaller models further expands the potential impact of their work, making advanced AI tools more accessible. This exploration into incentivizing reasoning through reinforcement learning not only advances our understanding of how AI models can learn, but also opens new pathways for creating more intelligent and adaptable systems. It's a step closer to developing AI that can reason and understand in ways that mirror human thought processes. Thank you for joining me on this insightful journey into the evolving world of artificial intelligence. Until next time, keep pondering the possibilities that such innovations hold for our future.